Morning, all. Welcome to Dnsop. Everybody's here early. Oh, great. Our area director finally got out of the chair. So, glad you all are here. Hey, it's early in the morning in Montreal. So, you know me, I'm Tim. That's Suzanne. And Benno, stand up. Our new chair. Take a little bow. There's Benno. Yay! So, we have lots of work for him to do. So, yeah, you know that. Dan York's doing JavaScript, Paul and Benno are doing minutes, and I think they're going to be in Etherpad if you want to actually make your own comments as well. You all have seen the note well plenty of times. This seems to be the new updated text, so take a read. You know, you're on point basically. So there's blue sheets passing around. I know this side hasn't seen them, but we'll make sure you guys get those. But please, yep, get those filled in. We got the smaller room, and the quick people got the bigger room. I was kind of annoyed by that. What are they? They're just transport people, right? So today on our agenda, we got some document updates. We got some current working group business, some previously discussed stuff. The new working group stuff we'll probably end up getting is going to be in tomorrow's 1 hour session. But since our last meeting, we have Benno. He's our new chair, and please be nicer to him. In other news, we have some DNS alumni in the news. You know this guy, you know, now president of ISOC. I don't think he's here, so El Presidente, but you know, we're very proud of him, so we hope you are too. So also DNSSD is looking for a new chair to work with David Knauze. It's a nice quiet working group, doesn't get out a lot on the weekends and stuff like that, but if you're interested, Terry Manderson, who I think I saw show up, he's in the back. He's a good person to chat with about that. I'm going to help David on Thursday, but that's just like just filling in for the Tim that's not there. But anyway, if you're interested, Terry's a great AD. It's a great little working group. They got some stuff going on. So, you know, please give it a thought. Also, the DMARC working group guys, which I follow for some work stuff, they've got 2 drafts that are in working group last call. And mostly they were looking at the ARC protocol one. There's some DNS stuff they wanted us to sort of look at, and I just wanted to call it to people's attentions. I know there's some folks in here, like Ms. Levine and myself and a few others who pay close attention to that working group, but if you're interested and you want to make sure people are doing the right thing DNS-wise, just take a look. It seems mostly pretty straightforward, but yeah, John waves his hand. You know, it's old news. So, we'll give you some quick document updates. Ooh, that's a pretty good one. There you go. So, excellent. That's excellent. So that's our document update. It's all in one place. I know what that is. That is refuse any. Yep. This is the quick HTTP2 version. Everything's on top of each other. So, but since I wrote it, I know what it is. I know we have refuse any in the ISG queue, and also session signaling. And what I was saying in that one is there are some discussions that were brought up during the ISG reviews, and Stuart and Ted have been working through basically addressing all of those, and they seem to be pretty much documentation, you know, editorial type stuff, and things all look good. But if anybody has discussions on that, please do so. Gosh, I hope the next one's better. Wow, this one's good. So we have 5 working group last call documents finished. KSK Roll Terminology BIS, which is finished. The 2 Adderleaf documents. And so my promise to you guys, and I've told the other chairs this, is by this Friday we will have all the Shepherd write-ups done. If I have to stay here Friday night and do them all, that's just the way it's going to be. Because my new policy is I'm going to bury Warren and work. So that's See if he's paying attention. No, he's not, so it's good. So, but it's time to move a lot of those over, and we're going to work with Benno on getting some of these out as well. So, this one's good. Here's one. In working group last call, finishes this week, capture format. We've had no discussion about this, no pro, no con, nothing in the mailing list, and silence is not equal consent in this matter. So we do need folks to basically say, yes, this should progress, no, this should not, what's going on here. So please, this week, just send an email either way to the working group and tell us what's happening there, because we think this is a good document and we do want to move it forward. But the big one, which is going to be more entertaining, is 5011 security considerations. This has gone back into working group last call. The document is now informational. It updates the key timing draft in a couple places, but there's some really rough consensus about this. And we got some comments this morning, and I know we have Mr. St. John. I thought I represented you correctly, but I did not. So please take the microphone.
The problem is that there was Mike St. John, sorry. There was working group rough consensus. There is no list consensus. So please stop saying there's rough consensus.
Okay, sorry about that.
Wes Rediker, USCISA. At this point, so I think everybody is well familiar with the dialogue. It was fun. It's over to a large extent. So the real question is, does everybody think that the document should go forward or not? So in my opinion, this is the cutting straw, and what we ought to do is ask everybody on the list, everybody ought to write an opinion, yes or no to the list, and that'll make the determination. It'll die or it'll go forward. And at this point, I think there's probably not much more editing that needs to be done. So really the final call is yay or nay. And so if you were abstaining from joining the conversation before because there was lots of math and things like that, read it again anyway, and just think of it in terms of, is it beneficial to the RFC series or not? As the slide says, it's informational, but just a yes or no. Now, there was very little input to the last consensus round.
Yeah, I see RAD there, and then I want to comment. Go ahead.
So, Warren Kumari, just as an author. So yeah, the authors, just so all of us note on that the name doesn't quite seem to line up. We're more than happy to change the name, just send email saying that. Seems like a reasonable point, and that's kind of what working group last calls are for. Point out things that were missed.
Yeah, so for what it's worth, as far as gauging consensus, that's actually the chair's job. That's what y'all pass the big bucks for, and all that coffee. But Wes is absolutely right. What we need is additional input, pro and con, so that we can call consensus, and so that our area director, with his different hat, actually, as a process point, because Warren is a co-author on this document, we have a different area director who is where we hand it off if we decide to advance it. But in any case, it's down to us and you in this room to call consensus on this and move it forward or not. Thank you.
As one final point, I mean, I'm
the physical and virtual room, because it's also on the mailing list for a reason. But that's where a determination of consensus has to come from.
I'm even, more than willing to state that if there is no, voice for it should go forward, then that's a fail, right? So silence, in my opinion, is actually a fail, and that's how it should be.
Yes, we agree with that. So, Mike, do you agree with that as well? Silence is a fail? Oh. No.
Yeah, Mike St. John's again. I agree with the silence is fail, but let me put one more piece here. It's going to confuse things slightly, sorry. I believe a document like this is useful and should go forward. I have a problem with the content of this document that I have expressed and tried to fix for a long period of time. In the current form, I believe this document is more harmful than good.
Thanks. And I apologize for misrepresenting you. I thought I tried to capture all your emails in the Shepherd write-up. And so I seem like I failed you some, and so I apologize for that. I will work on that, so.
Okay.
Up for adoption is a more lighthearted subject. The multi-provider DNS sec draft. This call for adoption ends on Friday as well, and it's informational. It describes operational practices. Shuman's going to talk a little bit, and we are an operational group. So it'd be, I know some people said this doesn't really kind of fit, but we had some people who were on the list said, yes, it does seem to fit what's going on, sort of thing. And, I think people are trying to do this today. So, well, I know we're trying to do this today. So that's all I have to say on that. Also, drafts just in. This stuff just sort of came in. QName Biz basically showed up this week, and I'm kind of very happy about this. It's initial. We feel the initial RFC was a big win in the privacy space, but we all got burned by some operational issues. Who got burned by that Bind 912 update? Besides myself. It wasn't even me. It was, yeah, I know people hide. And so this document we'll put it on standards track. My comment, which I believe the authors know, is we do need to flesh out the operational consideration section more, and that's a good thing. But we like this for adoption, and so if there's arguments about that, you'll probably see this coming up for adoption in the next couple weeks, basically. So. Also, this is just the link to the GitHub that we're working on with our document status. Ray's already pointed out something that I dropped, so I'm going to go update that. I apologize for that. And in the slides, it actually looks better than what we got going on now. So our agenda, Andre's going to talk about algorithm update. Willem and Andre are going to talk about cookies, operational impacts of cookies. We're going to have a fun discussion about something at the Apex. We had a discussion about SRV and HTTP yesterday. There was a sort of side meeting. There was some interesting back and forth between the two crowds. So I've got a DNS operations view / user community, and then Andre's got some stuff, and he's done some experiments, and Willem's done some stuff from the implementer side. So it's three of us are going to do a quick little round and sort of say feedback. But our goal here is I want to find a path forward. Everybody does this, we just have to figure out how do we sort of put the user community with the protocol folks together, sort of thing. That sort of thing. Multi-provider DNS sec. John's here to do a quick update about bulk RR. Paul's got a simpler power bind presentation. I think it's sort of shortened. And Davey's HTTP wire format, he didn't present it, but it's interesting because we adopted this before Doe, but this is really kind of looking like it's work that maybe is more in Doe, and so we'll discuss that. That sort of, I think, will be the, time of preventing sort of thing. So let's get started on stuff. It's Mr. Andre with algorithm update. So thanks all. Any sort of comments on the agenda? Any argument? Okay, so we'll just get going. Give me a second. Switch slides.
Hi, this is Andre Raisi. This is just an update on long-standing document on DNS algorithm update. Basically, this doesn't feel right.
Hold on. Do that.
So the goals of the document, if you haven't, who read the document? There's quite a lot of hands. So we want to refresh the list of DNS algorithms, add more as mandatory to implement, remove the old insecure ones, and do the same for the CDS algorithms. So this is a quick recap what the document says. It removes the RSA MD5, DSA algorithms. This recommends, it adds, This is for the signing side. This is for the validation side. So for signing side, this recommends the RSA SHA-1, but it's still a requirement for validators. it removes the ECC ghost because the ECC ghost that we implemented in DNSSEC has been deprecated by the Russian government. There's a new ECC ghost curve, but that hasn't been standardized for DNSSEC. So if anybody wants it, the work needs to be done. It promotes the ECDSA B256 to mandatory algorithm from like the recommended one, and it promotes the ED 25519 to recommended status with like goal to, after the implementation catches on, to require make this like mandatory algorithm to implement in the future. So for the CDS algorithms, we did a similar thing. Again, SHA-1 and Ghost is forbidden to be used as a DS. The validators still must implement the SHA-1, and it may do the Ghost if the implementations want to do that. So the other change we did, we like changed the algorithm that's mandatory to implement, and every implementation must implement it to ECDSA B256. And we think that we address all the comments from the working group, and the documents ready for working group last call. So if you have any comments now, we would like to hear them.
Have you got any pushback on using the curve algorithms from the vendors?
No.
Okay. Oh, sorry. Chair is asking if there was any pushback from the vendors on implementing curve algorithm, and the answer is no. So,
Well, most of the curves that, the ECDSA is now well implemented in all crypto libraries. The ED, DSA is in the recent OpenSSL and the recent TLS, and I have no idea about what's the other one, the Mozilla uses. Oh, never mind.
Yeah, John Levine, I just have a general question, which is, I mean, to what extent is this macro already implemented in the DNS servers we are likely to be using? I mean, is this mostly implemented, or will this require a bunch of changes?
No, it's as far as I'm aware, at least ISC, Newland Labs, and CZNIC has all these implemented. I have no idea about Power DNS, but I would guess that at least ECDSA is there. And well, I know they were first to implement the EDDSA, in fact. So it's everywhere is implemented, like for things we care. I have no idea about the proprietary implementations. But if there's somebody from those vendors here, would like to hear from them. But I think we covered most of our bases.
Mark Andrews, IC. You also need to look at this for key and 6.0. Do the same exercise. Add
Sure.
another table, because it's been a long time since we've done any housekeeping on key.
Sure.
Key for
Like
6.0,
this.
so I suspect the same set of
Yeah.
requirements and must, and things will come out of that.
I had a presentation at the ICANN DNS symposium about, like the old stuff in the DNS. And that was one of my points, that we should do stuff like deprecate Diffie-Hellman and add elliptic curve Diffie-Hellman to Tiki, and update the 6.0, define the transactional security to 6.0 for the new algorithms. But that's out of the scope of this document. I'm happy to collaborate on a new document like this, but let's not stall this any further.
I'm not saying this thing has to be new. It's related, whether it's this document or it's something that needs to be done.
another document. And then Jeff, and then Paul.
Jeff Houston, slight normative terminology question. What's the difference between must, uppercase, and recommended?
Well, that's in the RFC. The recommended is alias for should,
Why don't you just use should?
because it feels like natural language better.
But it's one level down from must.
What's the difference?
So it's must or should now, and it's a weird table to understand.
I could change it to should, but it's Because it's equivalent and it's defined in the RFC, I don't know the number, that defines the must and shoulds. And the recommended and not recommended is alias for should and should not. And it felt to me that because we remove all those pluses, minuses, that the recommended feels like you should do that. Like,
Which is
we recommend,
which is different from recommended.
I don't care. I don't care if should, this
All
is just
I can
simple.
say is it confused me. Because the use of must and must not is easy. But the recommend is kind of stronger or weaker?
Just for clarification, because this, just to see if we have a path forward, it sounds like what you're suggesting, there's a little bit of issue with understandability here with mixing normative and non-normative language.
Right, so I'm going to sign. Should I do one of the musts or the recommended?
Right, and it turns out that must has a specific meaning in the process we're talking about, and not recommended does not.
It does.
What I'm hearing, let me finish, what I'd like to suggest, what's the normative term that's the equivalent of not recommended? It seems like an easy change to make. Should, yeah. Should not.
The document,
Jeff, will it make you happy? It will be okay to say should not instead of not recommended.
That'll make me
the
happy.
document, the document that defines normative language specify that should is equivalent to recommended.
I just want to get past a terminology issue because it doesn't feel substantive to me.
Out of Colleman Internet Society, but it doesn't matter now. RC 2119 says, should this word or the adjective recommended mean there may exist valid reasons, blah, blah, blah. The RFC puts them on equal setting and recommended is a 2119 equivalent to should. So.
Thank you.
We can mention that.
Okay, Paul.
No, but I specifically used those words because I read the RFC that Olaf just quoted. I know that it's not commonly used, so I'm happy to change it back to should not and should, but.
Well, neither of you speak the proper English anyway, so, I mean, you speak the Queen's English, so. Yes, it's nice. Okay, Paul, and then.
Michael, as at the end, I propose to change.
Paul was first, sorry. Oh, sure. Yeah, let's get Paul in there.
Okay, so I just want to make a quick note in response to Mark Andrews about the TSIG and 6.0 algorithms. Those are actually lagging much more behind other ones. So for instance, if you were running a Red Hat server, then only recently could you use something that is not as weak as HMAC MD5. So I think we should be much more conservative with those, and I'm not sure if we should pull them into this document.
Okay, sorry. Just wanted to say, I would propose to change the must into required.
Is that normative language?
Yes, it is. It's equal in 2119.
It helps to be a fan of iron.
Hi, I'm Jim Fenton. I just want to clarify that this has to do with the implementation, what goes into implementations, not what you actually sign with, because I'm concerned, especially looking at the ED 25519 line, it's sort of saying recommended, but it's only recommended on the validation side, which seems like it could produce an interoperability problem if people actually took that seriously.
Well, the recommended, if you read the draft, we use the recommended as a way of saying this will become must in the future, so please implement it now, so it doesn't create interoperability problems in the future.
Right, so I'm saying maybe, and I apologize that I haven't read the draft, I'm responding to the chart here, that this has to do with implementation, not actual use in the field.
Yes. Yes.
Thanks.
Okay.
Well, actually, I have a question if nobody else does. If I heard you correctly, there's, implementation discussion on some of this, but I don't immediately see it in the draft. Would it be a big challenge to add a brief implementation status section?
Sure, sure. That would
Just
be-
because that's something that we've discussed frequently in the working group recently, and people have, people seem
That
to like.
makes sense. And just maybe more comment. This is for implementation, the fancy color tables. But this is like the deployment device.
Warren.
And I do see people at the mic now.
Too short down here. So Warren Kamari, just on the previous point, I know that the document does talk about, this should be implemented and it's not what should be used. But lots of people will just flip through documents and see like the big table and assume that that's what they should use. So you might want like H1 blink, red text above and below the table being like, just a reminder, this is implementation, not what we're recommending you deploy right now.
That's why there's a paragraph about what should be deployed. Like this is the golden standard.
It's not, that's, I think, further up in the document. I think having it nearer the table as a,
Okay.
you should have actually read the rest of the document, not just flipped to the table, but seeing as everybody just flipped to the table, just an extra reminder.
Tail, I'd like to actually ask that you not make it blink, as Warren just asked. That I think is a terrible idea. But actually, what I got up here for was I'm curious, do we just need a really quick hum on agreeing that the must and recommended language is just fine without switching, or the must and recommended without it switching to required, or just, I think we're really actually mostly in agreement that we're all okay on that, but since we heard some, suggestions that different terms should be used, let's just, a quick hum I think might be a good idea.
I was also planning to suggest taking to the list so people can think about it a little bit more, but sure, we can,
And we can surely use more reviews from the working group, as usual.
but sure, we can, no, but I appreciate the suggestion. For those who feel that the current language in the draft is understandable for their purposes, so we are not asking the editors to change it, please hum now. And those who feel strongly that it should be changed, that there's a problem with understandability, please hum now. Okay, that's informative. No, it's informative. Okay, so what that sounds like is with a little bit more of implementation status and advice. That's what the working group is asking you to do, and that should be a relatively straightforward revision, and then we'll do working group last call.
Yeah, that makes sense.
Let's move it.
That's right, you're next.
Yeah.
Yes, we have parked the bike in the bike shed.
Yeah.
Okay, so DNS cookies are a countermeasure against all sorts of off-path attacks. But most notably, perhaps the one in which the attacker uses a botnet to send queries with a spoofed source address, and the address is of the victim, and it sends queries to a name server asking for a large answer, and as such overflowing the victim with a lot of traffic. So the time that cookies were emerged, the idea was, well, the problem is that there is no handshake between the one that sends the query and the one that gives the answer. And one solution is to use a stateful transport, but that doesn't scale very well with DNS because DNS can currently scale to many, many queries a second because there's no state at the authoritative server. TCP keeps state for every client. And so the cookie is a way to address this with just having a single secret on the server. process of DNS. It's a sort of handshake. If you have made the handshake, you are known to the authoritative server or the resolver for that matter. It doesn't really matter. It works for both step to resolver and resolver to authoritative. If you have made the handshake, then you are a known client. You get the large answers or the better responsiveness. If you did not make the handshake, then you will be get a short answer or will be subject to response rate limiting or some other policy. So the operators of DNS that had to deal with amplification attacks immediately, they had to deal with it immediately and implemented things like priority lists for the known resolvers. They kept statistics on these are the golden 50 resolvers that we always see, and they will always get answers, and dealt with it that way, and also with response rate limiting. But the vendors of DNS software saw it as a protocol flaw and thought we can deal with this in the protocol itself. And so that's the reason that we push for this DNS cookie draft or RC. And but there's an issue with, it's important that all vendors do the same thing, of course, and especially in Anycast deployments, that the same cookie or the same algorithm is deployed amongst all servers that participate in communication for a certain IP address. And so, operational practice.
And with that, you have me back again. So the operational impacts, the good operational impacts is that the servers can have improved policies based on cookies. So if you have a cookie, you can, as William said, you can disable RL, you can do all fancy stuff to like deciding what's a legitimate client or what who's not. You can have a better responsiveness under attack because you can like roll away, like it's without cookies and redirect them to TCP to get a cookie. But the bad side is that in Anycast situations, especially when you deploy like multiple vendors at the same IP address, which happens quite often in current world in Anycast, especially at the root and TLD level. And then you have a problem with state synchronization. So the Anycasts are the like most problematic ones because there are multiple implementations deployed the same Anycast node, and the deploy server should share the same server cookie secret and same cookie algorithm, even though the clients should handle multiple cookies if they are compliant. But in the real world, you can have a mix of servers with and without DNS cookies. They might have a different deployment schedule. You just deploy a new version of bind that has cookies, but you have like NSD or NoDNS or Power DNS at the same node, and they don't have a cookies at the same time. So now you have at the same Anycast node hidden behind the same IP address. You have a different servers with like different state of the implementation. With cookies, without cookies, different cookies. It gets too confusing for the operators. Well, from my experience, you can also have like an F-root, a different operators for parts of the cloud. So there's parts of the cloud for the F-root that's provided by SC. The other part is provided by Cloudflare. And again, these are different implementations with different like cookie, and there's some like need for synchronize those cookies. Otherwise, it might feel like wrong. The other thing is that the unconfigured server pick server secret at random. So again, even if you deploy multiple instances of the same server and you don't configure it, you now have a like different server cookies hidden behind the same IP address, even though you have the same server. The other thing is that there's different default algorithm, and there are incompatible algorithms in what the input data goes into the function. It doesn't have to be a shape function. And there are also deployments, and this is with the permission of RIPE and CC. The K-root does fancy thing to the routing. So almost every time you ask, you get a different implementation. So if you run a loop over the K-root IPRS, so it's not only a routing problem like with the BGP will switch, but it's a local problem for the nodes. And you are still connected to the same anycast node, but they rotate the implementations that answer the query. So on every query, you get a different cookie based on the server you just hit. So the solution we will work on, because this is vendor initiative, we will probably do this as a vendors. We will define, we will write a new draft that will define the mandatory algorithm to implement between the implementation, similar thing to what we did to the DNSSEC algorithms. So both the crypto functions and how the input data into the function is fed will be standardized as this is mandatory. We want to add a SIP hash. This is a pseudorandom function. This is exactly designed to things like network traffic authentication. And it seems like a best fit because it's fast and it's designed for this kind of thing. And we'll define optional algorithms to implement because they are already there, like HMAC, SHA-256, and AEC. The other thing is that we probably should remove the non-cryptographic secure algorithm. There's been FNV algorithm defined in the original draft, and that needs to be removed because it's not really suitable for this kind of use. And the document should provide the guidance both to the DNS vendors and the DNS operators how to deploy in such scenarios. So, any questions? Before my own company eats me?
Francis Dupont. So,
I think Paul was first.
Paul,
I'm in front of you. Can you go back one slide?
Sure.
So mandatory algorithms, but you still have a lot of options. Can you explain that?
No. If you think we should have just all of them mandatory or all of them removed optional and just one,
I'm not suggesting, I was just asking for clarification.
This is very preliminary work, but there's a real need to define such a document. So we might decide to remove the HMAC or AS. I would like to just have one algorithm, but I think we need some algorithm flexibility for a future in case, well, DJB will be wrong because it's DJB's function with some other outdoor specification. Okay, Francis?
So, Francis Dupont, I'd say for the choice of the right algorithm is not for us, it's for a cryptographer. On the early age of DNS cookie, Mark Andrews asked me what to use. And I just forwarded the question to a cryptographer. So say, HMAC is the obvious solution. And the answer, EAS is better, it's faster, it's at least twice faster. So it's a question for a cryptographer. So you give it to a cryptographer and say, what to use?
No,
safe, simple,
we can definitely use CPRG as a consultancy for what algorithms we should choose. But I know that there are many cryptographers here in the Dnsop, and this will be a working group document, so I guess they will chime in. Yeah.
Hi, this is Donald Eastlake from Huawei. So I'm the author of the Cookie RC, one of the authors, and I'd say we're working on revving it to include a mandatory server cookie. It only really applies to server cookies that you have this problem that you need to standardize. One for interoperability between multi-vendor Anycast server pools. So I think that there may be other improvements advisable in the cookie draft. I think the right thing to do is to rev that draft, and would welcome other co-authors in doing that.
Well, I count on you because we already talked about quartering the draft, so I sort of count on you will join this effort. Right in draft, right?
You're asking me to join your draft?
Well, no, but we talked before that you would like to help with the draft,
Yeah.
right?
Yeah.
So you are on my list of people to
Okay,
write when I'm starting writing the draft.
okay. But maybe it can be merged or whatever.
John Reed, Akamai. Can you go back just one slide? Okay, so you mentioned a couple times about the Anycast problem, and I've heard you say multiple vendors at the same Anycast node. I just want to clarify terminology. Are you talking about actual different DNS software at the same Anycast node? Or, okay. What about the situation of same vendor at multiple Anycast nodes where the route may change between queries?
That's not a problem because the cookie is server specific. So if you like the name server has a cookie, so the client is a client server, not client domain, so the relation. So if you have multiple name servers with different IP addresses, that's not a problem because each of them could have a different cookie.
Well, I guess I'm asking, what if the response goes to, so the server sends the cookie, right?
Yes.
And the cookie then, in the response, the cookie in the response has to be something the server knows it generated, right?
Yeah, it's calculated from the client cookie and some other variables on the server side.
So I guess I'm just saying, to the point about providing guidance to operators, it would be great to have some specific recommendations about how to handle that type of component.
Okay. Olaf Purvis first?
No.
No?
Jabber?
Jabber.
Well, no, for some reason, my Icelandic colleague over here wants to have the last word or something. So Dan York and Mike, just to the point about the different algorithms there, I think we have to go back to the audience, right, of this. And if we want to make it for implementers to implement, I would encourage us to not have options or to make it as clear and simple of exactly what we want people to do and to not provide too many choices, because this is going to be handed to somebody who's told to go write this or add this into something, and they're going to go look at it and say, what do they have to implement? And so to the point where we can give them the clearest and shortest list of things would be ideal.
The only thing I'm afraid that if we just make only one function mandatory and there's an severe degradation of its security, then we won't have a second choice.
So then make two algorithms mandatory. I think the question is, if this is handed to Wes and Wes has to go implement this, Wes is trying to do 57 other things, and he's going to look through this and say, what should he do? And he's going to pick the one that he has to do, which is the one that says must. Okay, because Wes has other things, and it's going to take him more cycles to do those other pieces. So he's going to grab that. So effectively, we're creating more verbiage for little result, because somebody, now maybe Warren will go implement the shoulds because he thinks it's a good thing, all right, but others will not. So I think keeping that, and if we need two algorithms, do two algorithms.
Okay, makes sense.
Can you go to I think it's the second slide?
This one or the previous one?
No, go back. Go back. Go back. Why? Okay. So, or is there one before that one? One back? Okay. So basically, DNS cookies, what is it trying to solve? And if we look at this from the perspective of the camel, we have, for the handshake, we can avoid cookies totally if we do TCP. Right? Wrong?
Out of the scope of this work.
No, it's not. This is a question of alternatives. This is extra work. We are going to spend a lot of time talking about it. We can do the same thing with the existing technologies. And so why do this?
So you're suggesting to kill the cookies?
Yes.
Then
yep. I think this is not a good idea. And if you're thinking about it,
I'm solving the current problem that we have.
I'm saying we have the existing solution, which is TCP, which solves most of the problems that the cookie is trying to solve.
Maybe.
So,
maybe. But I'm solving the
no
problem that there are different implementations with different algorithms being implemented in in the cookies, and I need to solve this problem. So if you want to just kill the cookies, please write a draft to kill the cookies and let the working group decide. But I'm continuing this work because I have a real problem to solve.
And one of the solutions you could do in this draft is to say, please don't deploy cookies, use TCP. I'm trying to outsource work here.
Yes, we can tell.
Now, real quickly, you had a quick. Oh, Marcus, just to reply to that, actually. We have a number of drafts, including things like DNSSEC chain, and I think we have like the TCP persistent one that actually talk about cookies and say like you should really do something to protect the UDP channel if you're using UDP. So even though we do say TCP is an option, there's definitely already RFCs out there that say please use DNS cookies. So you cannot just kill it.
I'm Tariq Siraj. Having cookie exposes the privacy first that it will show that the large messages will be exchanged first, and the second thing is that how cookies will impact the DAN protocol. I mean, if they are exchanging certificates and if there is some kind of cookie injection attacks occurs, will that impact that protocol as well? I'm totally confused about that in having cookies.
Again, this is out of the scope. The DNS cookies are already there. This is the work about standardizing on one common algorithm that all implementation can do. So I would advise you to go to read the DNS cookies draft, the RFC, sorry. There's an RFC on DNS cookies. Please go read it, and it has the answers. So, but no, it doesn't do anything to the privacy. And if you are on path and you can inject the cookies, you can read it like the answers and responses anyway. So there's no. But again, this is not about the DNS cookies. This is about the standardizing single or two algorithms for that all implementations will support.
Thank you.
For those who say we should be using TCP, sure, we can use TFO with cookies. Still use cookies. Run security.
Ted Lemon. So this is kind of a little bit on the same topic. There was a presentation in Interia yesterday about PMTU issues, and basically the recommendation was don't use fragmentation, which I know seems slightly off topic, but of course the reason why we have that issue, the reason why it's an issue is because DNS, particularly DNSSEC, tends to send large packets around, large UDP packets around, and so those can be fragmented, and that creates pretty serious problems. So this is essentially another reason to consider the solution of just saying don't use cookies rather than trying to make cookies better.
Okay. But the cookies are small. But I understand it. I understand it, like your point.
Yeah, I mean it's.
But I have the problem with like not doing anything. So if we want to kill the cookies, let's kill the cookies. But I won't like stand and do nothing. So either let us kill the cookies or improve them so they are usable. So not improving them and keeping the status quo is not an option, I think.
Yeah. I think the point that you're getting from the people that came up to the mic, including me, to talk about this is just that we really ought to actually open that question before proceeding with this further, because and not make a big delay about it, but just like have that conversation, because I think that we had a conversation in the last IETF about how much extra crap there is in DNS and how maybe that's a bad thing, and here we are talking about how to make I mean, this is essentially a problem that's created by the addition of this new feature.
Right, that's I see. I know because I've heard from them, spoken to the operators, that are operators who want to deploy cookies and can't currently do so because there's not consistent implementation of the algorithm on the server side. We've got to do this.
Well, even though it might be like wasted work, even if we proceed with improving the algorithm so we have a common implementation and then kill the cookies, I think it wouldn't be wasted effort because it would improve the solution for like the people here. The operators. Oh, I fear that moment.
Okay, Bruce.
Do you want to kill UDP for DNS? That is what you're asking for, literally. You are saying, get rid of DNS over UDP. That is what you're saying. Get rid of it completely. Cookies work with unfragmented packets. Fragmentation is a separate issue to cookies. They're a orthogonal issue. And you're confusing the two.
So to be clear, I'm just reporting on something that happened in Interi and the implications of that. I'm not personally arguing that we should.
Okay.
drop it.
Okay.
Hug it out, guys.
Okay. Cookies do multiple things. They protect against amplification attacks. They also protect against spoofed responses. I really don't like having to open a new socket basically for every single query over UDP. Cookies have two sides. They've got a client side, a client cookie as well. That's designed to give enough entropy to the question that you can guarantee that you're not getting a spoofed response back. We can go back to a single socket for UDP with cookies. I think all the DNS implementations would like to be able to do that, because managing thousands of sockets to get queries back is a pain in the... Yes. Okay?
Yeah.
So...
Okay. So, Warren.
Yeah, I believe Mike was next.
So, and cookies work for unfragmented packets as well. They provide protection on unfragmented packets.
Okay. So Warren Kumar again without hats. So regardless of whether or not we deprecate cookies, and I've got my own views on that, it seems leaving things like this is dangerous.
Yeah.
And it's going to be a while before cookies can be actually removed everywhere, if that were the idea. So it seems like fixing it instead of leaving it as a rake in the grass to trip over.
Because we are very good at removing stuff from DNS.
Paul and then Jan.
Okay, Jan Chart, S1. So I just want to react on the UDP stuff because I think this is no longer relevant in our world. For instance, HTTP world is able to handle like thousands of TCP connections with very high performance. Someone said TCP fast open. It's another mechanism how to like decrease the latency, and it has cookies protection like built in the protocol. As a DNS server implementer, we don't have cookies as NS1, and we don't plan to implement it because the amplification factor in our case, because we use online signing, is much like lower. And another thing that I want to point out is that cookies are really difficult to parse and process. It's quite expensive. And once you get to this point, you have the cookie parsed and validated. It's maybe easier just to respond.
So Paul, Oliver, then Dave, and we'll cut the mic line on that one. How's
I
that?
just want to, again, the response what you said is what Warren said. It's a mess right now, and it's we fix even if we kill the cookie in the future.
I'll allow to thread that. I just want to say that I would like all the open resolvers that are accidentally added to the internet at all the times that we currently have to have enabled DNS cookies by default so that they're not part of an amplification attack. And even if that is the only goal of the cookies, that is a useful thing to have. So please do not kill cookies.
Basically, I think if we're going to spend any time and effort on things like this, we should make DNS over TCP better. We should have longer lived sessions because we have bursts from clients, and we should just bite the bullet. UDP is not good enough except for certain situations. And regards to what Mark said, get over it. You have to deal with lots of sockets. You have lots of addresses to listen to in many cases. So
with my ISC hat on,
I would say
that's definitely what we plan, improve the networking.
Yes.
But this is this is matched right now. We have cookies
my
right now.
recommendation to the working group as an individual is let's write kill cookies draft.
And Schwartz. So we've heard definitely a lot of interest in cookies from certain, I guess, recursive and authoritative
vendors. I'm really interested to hear if there's anybody who writes stub resolvers or is responsible for large-scale stub resolver deployments effectively that has implemented cookies or who plans to implement cookies. And I'd also be interested to know if between recursive and authoritative, if anybody has operational experience that would inform how useful the cookies have actually been. Not necessarily in the meeting, maybe on the list.
Willem Torop in NetLabs. Labs. Stub-level cookies are in the GetDNS library, so also in the stubby daemon.
Dale, I just wanted to back up on Warren's point that this is already an existing mess that really needs to be addressed on its own. I really strongly disagree with Oliver that the solution is just TCP everywhere. You are going to get tremendous pushback from operators on that point. While Cloudflare seems to be quite happy to go that route, that is certainly not universally the case among providers. And I think no amount of improvement in the, say, lib-bind networking code is going to really change that situation very much. And beyond that, one of the things that, in this room where we're mostly DNS people, that I think a significant part of the community is overlooking is the existing tension that we have with one of the primary uses of the domain namespace, which is the HTTP community, and just how they feel about the, any possibility of adding more resolution time into DNS queries, right? Like this is standing alone here and saying, oh, well, everything will just be better if we could just, go to a secure stream protocol is not necessarily going to fly, at least with DNS TCP as currently defined.
Yeah.
Dan, I would just say.
We did close the line, but you got a few seconds because you're the scribe and we love you.
Oh, well, thank you. I would just say to Oliver, I understand what you wanted to do and the thing like that, but I would say, how successful have we been at massively upgrading the global DNS infrastructure with any kind of change we wanted to do in any kind of time frame, right? So I mean, yes, we can all have an aspiration to go to TLS everywhere or something, but it will take decades or something at the way we are currently able to change the overall global DNS infrastructure.
So it does sound like there's a new draft in our future. It would be, and I think the larger question, the working group does have to engage on whether, on the effort of, and we're not talking about whether people will do this or not. We don't control that in this room, as Dan pointed out, but whether the effort to document as an RFC and standardize is that a good thing for the ecosystem. So we'll go ahead and consider that when we have a draft. If somebody dearly wants to write the kill the cookies draft, I think the working group should consider that also.
Andre, before you go, I have a clarifying question. Actually, it's for Don. Don, I just looked through the drafts directory. You don't have a draft on cookies. I thought you said you did. Ah, okay. Sorry, no, so then you two might do, okay.
Oh man, how do you follow up a great cookies discussion? Let's talk about the Apex. Hey, so this is going to be great fun. So there was a couple of side meetings about this stuff, and one of the things about the SRB meeting, but this is something that we want to sort of see if we can figure out a path forward on. I'm going to talk about some stuff from the operational community because I'm an operator and this is Dnsop. And Andre and Willem have some sort of implementer, sort of other views in the world and some experiments they've done. So let me sort of go on a bender here. So we are seeing So why do we need this? Because SRB works, but it only works with robots. Humans can't deal with SRB. A and Quad A work, but it's not unless it's a CDN, right? Users should know better, but they're users, right? And this is not going away. I think you know that. This is what I see. We have a generation of engineers now who just assume that you can have a CNAME or some sort of synthesized record at the apex of its own. Why? Because the Amazons, the Googles, the clouds, it all supports it, right? And when I tell people this is not a standard, they say, but it has to be a standard because everybody has it, So it's like there's a disconnect between the user community and the protocol people. And I feel that we need to fix that somehow, And so I manage a lot of production zones. I work for a little cloud company, and I wanted to be able to sort of do those production zones in some sort of cloud instance to be able to be multi-vendor. And right now, we can't do that, right? So how do we sort of fix that problem? I do think it's something that is out there, and everybody supports it, and so, I do think this is the smartest group of people I've ever seen. And it's like, we should be able to fix this. It's like, you guys are way smarter than me. And it's like, I have a zillion different ways of how to fix this problem, but none of them seem to be the right answer. But you guys are way smarter than me. Everybody I talk to here is always much smarter than me. And I always feel much more enlightened by that. It doesn't need to be CNAME, it doesn't need to be 80, it can just be something, right? We need to figure out how to move this forward and a transition plan for all these zones out there. Now, there was an interesting talk at the Applied Networking Workshop on Monday. Mark Allman, not Eric Allman. I don't want to get him mixed up, where he was talking about the dying attack and second level domains and the sort of the robustness and stuff like that. And it's not there because, people, they just deploy from the Amazons and, Route 53 is all good. And once in a while, they have a bad day, right? We all have a bad day. And I don't want to go in front of like a whole bunch of executives and employees and say, we had to stop printing money for my company because, Amazon had a bad day. Because the company I work for, that's essentially what I tell people, they just print money, okay? It's a crazy little company that's what they do. So I think we can solve this. Maybe we can. So.
Lars Lehman from NetNode. Can we please have a clear and concise problem definition?
Yes, I do think we need a synthesized record at this apex of a zone that can be CNAME, it can be something. It has to be something that is like a CDN can use, right? Or some elastic balancer service, for example.
To redirect an entire zone?
Or just that, or just the root of the zone. Because we want root and we want dub, right? Everybody wants both.
Okay.
How do we solve that? And trust me, it's like when someone forgets to like put the root of the zone in a cert, and there's a major issue, right? Well, yeah, I think, but you want to, if you want to just yell at me, it's okay too.
I'm not going to yell. Just go back one slide, please. So, works on the Amazons. There's an interesting thing that I think Con McCarthy, I'm not sure you say that, wrote back on, I think, 25th June, that kind of slipped by. Amazon solution only works if the target of their record is hosted on Amazon.
Yes.
Because they already know the answer.
Yes.
And that's a very crucial difference.
But their users don't know that.
Yeah,
that's the thing.
Know that, but that's what we're up against.
Yes.
It's misrepresenting what they're doing because they do not have a generic pointless anywhere on the internet solution.
Exactly. We need to be smarter and better than that, and I know we can be. I'm not dissing Amazon. I just think it's it's this gap thing.
I'm not sure I agree with the definition of the problem. I mean, for me, the problem is that users have a domain name, and they want this domain name to be hosted somewhere in a CDN, etc. So they deserve some sort of indirection between the domain name and the server name. We already have a clean solution for that. It's SRV. Now, I've been to the HTTP SRV meeting yesterday, so I know it's not easy. There are a lot of problems, but my feeling is that whatever solution we find with CNAME, ANAME, it will have also more or less the same sort of problem, corner case, transition, etc. So I suggest not to frame the problem as I want CNAME at the apex, but rather I want an indirection from domain name to server name, and then we have several possible solutions. And in my opinion, the best one is SRV.
I'm willing to go anywhere with that, and I'm just saying we just need that and a path forward, right? Because then if we can pick something that we can move forward on, and it's something we can, build tooling around, then we can get a path forward and we can, I can use my stick as a vendor, as a, customer of a lot of vendors to beat on them to make changes, right? I'm very willing to do that. So I like doing that, So yes.
Relaying for Tony Finch. This also needs to support alias plus MX for subdomains not at Apex.
Yeah.
So, and I'll put on my hat and say to Lars, so the problem, right, is that we all used to run our websites, well, many of people run our websites on www.example.com. But then we got tired of saying www, so we started to just say example.com.
Yeah.
And now we want to do that. And then we got tired of running our own websites, so we wanted to push them out to CDNs or to other hosting providers or other things like that. And so that now we all of a sudden can't do an IP address. And so now, all of the people who are running around want to say, I just look me up on example.com. And I mean, that's the problem, right? And so now if I want to do some kind of pseudo CNAME thingy, I have to go to whichever vendor is hosting my stuff and use their own proprietary CNAME thingy that they call something else, right? And is that, Tim, that's what you're saying we need to fix here.
And I bet if you go and you pull the .com zone and you look at the NS records, you will see probably the largest percentage of AWS records in there, right? I don't know that. Somebody can go, but that's what we see. I want to get to a place where I can actually support, domains in sort of multiple places that I can actually transfer between multiple vendors, right? Help me get there, right? You guys are smart. Help me get there. I'll take whatever you give me.
Well, and I don't want to be stuck using somebody's proprietary situation for my website thing. I want to be able to have control of my zone and put in there some CNAME thingy that lets me go and point to whatever CDN or hosting provider I'm using today.
Yep. Help me, Lars.
Exactly. Fair enough. I picked up on the problem. So, yes. So I have two preferences here. Please don't overload the CNAME thing. So
I agree.
If you want to do something, please invent something new.
I'm totally
kind of okay with that. The second one is that my personal preference would be to go with the SRV solution, but I understand that there are complications and implications for that. So just not CNAME, would like SRV, but if you have to do something in between.
That's why I called it something, right? Just give me, give the world something that we can all sort of standardize on, right?
Yeah.
Wes and then Mark and then Andre's gonna.
I think Mark was first.
Okay, sorry, Mark. Go.
As we said earlier, we had a very productive discussion yesterday. What I really think we should do is have a combined HTTP DNS meeting at the next IETF, 2 hours long minimum.
Yep.
And lock us in the room until get the chains on the door, put the padlocks on the door.
And you're inside, right? And you're
I'm inside. The HTTP guys are inside.
Okay.
And have the bun fight until we come up with an agreement that they're going to move a little bit, because they have not moved in 20 years.
I'm willing to sort of chain those doors. And that was an interesting discussion. And Shane Kerr wrote some great notes up that I think he posted at Dnsop. And one of the things I asked him about was, I think they should be attached to our minutes, because I think there were some really good conversations that went on in there. And I'll ask the people that contributed if they're okay with that as well. So, but yeah.
Wes Hardiker, ISI. I keep falling on both sides of this fence, and I'm never quite sure where I'm going to land when I actually get to a microphone. But
it's the 5011 fence, Wes.
The reality is that we are being asked to solve a problem in DNS for another protocol's problem, right?
Well, we're solving something for the users. Okay.
No.
Yes, we are. We're solving the programmers and the engineers that all deploy stuff. They're the users, right? They're our customers. Aren't they?
Every protocol is our user. So, no, wait a minute. So two things. One of the reasons that I'm not falling on one side of the fence is that the problems associated with putting a CNAME at the apex are not exactly clear to many people.
It's horrible.
There's weird things. Yeah, but let me say that maybe that there is a better solution here, right? Maybe the right thing to do. The reason that serve records don't want to work is because then you have to do more lookups, and that's bad. And we already talked about the TCP delay a second ago. Here's the deal. That doesn't prevent software from offering sort of better solutions to the people asking the question. If you're asking an A or a quad A of the apex, then maybe you could return the serve fail, excuse me, return serve fail. Yeah, exactly. You could return the serve record. I mean, there's other ways around it without actually changing, without having to change the back rules. Now, whether that rule is important or not, I'm not so sure because nobody seems to be arguing that side of the problem here.
I can also just deploy everything with Terraform and just push everything that way, right? I mean, that's the other answer.
But I'm not really happy with the DNS protocol being asked to change significantly in ways that have been traditional for a long time because another protocol has an issue with how to use it.
Because it becomes so popular that people want something that they demand, as well. Mr. Joel.
Joel Yeagley, I personally reject the notion that this is driven by demand from another protocol.
Yeah.
This is driven by the meat bags who are typing on the keyboards on the other end, and they want convenience or death.
Yes.
Right? Those are like HTTP, it didn't cause this.
Yeah.
Right? The fact that someone wants to type one word caused this.
You're right. You're absolutely right that it was not the protocol's fault. It was the user's fault and the operators in the deployed world that is using that protocol, though.
Yeah. So what they came up with is an egregiously bad hack that is intended for the convenience of the users. There are alternative egregiously bad hacks. Our service actually allows you to host your Apex on TCP Anycast if you absolutely want your Apex to have an A record and end up in the topologically closest POP. That's not a great way to do this either. I'm not proud of that at all. But it is a workaround that exists specifically to address this problem.
Yes. Thank you. I think he had a jabber. No, okay. And we'll kill it after Lars or,
We're fine for time.
okay. Oh, no, I'm tired of listening to people. No. Go ahead.
Roy Adams. About 14 years ago, I was working in a company and they wanted to have this specific hack and I didn't know how to do this. So I came up with the following, and we all know this hack. The idea is basically instead of hosting your own zone, you locally host the parent, right? So you can have CNAME at the label. Now, this was a terrible hack, and and a lot of people have done this, and I just checked. It still works. They still have it. And it's a horrible hack. We need to get away from that. And I love this discussion. I think it's very, very important to solve. If we don't solve it, those hacks will remain and will remain forever. It also means you can deploy DNSSEC, et cetera, et cetera. One thing I learned last week about minimal responses, it's a bind configuration statement, is that you can make it so that it doesn't respond with the NS records in case of an NX domain response. Right? In the absence of NS records, who needs NS records as a child anyway? They're not necessary, in my humble opinion. They confuse a hell of a lot of people. So we don't need NS records at the apex. What if we just do this paper exercise? If a CNAME is at the apex, what would break? And then we look at these individual things.
Yeah, I'm not saying I swear by CNAME, right?
I get that. But I haven't seen your presentation, and I know that a lot of things will break, but it's good to have a list of exactly what will break.
And he broke it all. It's great. That's why I love him. He's great. He breaks everything.
Yes, thank you.
Did you have it? Okay, Jared?
Hi, Jared Mach. I may or may not work for a company that abuses CNAMEs for a living. So in looking at this, I'm reminded of, DNS is, first of all, a very old protocol. It's one of the older ones on the internet of several that have been used. I'm reminded of what happens with, the many applications that I've used over the years. So using SMTP, using Gopher, and using like a variety of these other services that inherently date me of looking up stuff on Archie and such. So in looking at, yes, thank you. I'm trying to melt your brain. No. So in looking at what happens, there's a lot of special handling cases for how applications deal with certain things like CNAMEs. Like the mail servers, if you email a CNAME record, it will actually rewrite the addresses and the headers to go and match wherever that CNAME follows.
Used to.
And it may still, depending on how you're configured. Yeah. So there's a lot of like historical experience with how we handle this. But there's also, if you would email, a host name and it didn't have an MX record, the SendMail, Postfix, whatever, will try that direct IP address, which is what we're seeing from many of these applications today. And it seems to me like an acceptable way to address some of these things is to go and assign some record types for these applications. They don't have to use them, just in the way that mail doesn't have to use them, but we have the opportunity for them to use that capability to then go and follow something, be it the A name, or, the alias or whatever, and go and provide a method such that somebody can do stuff. So they can go and say, hey, I want to do multi-CDN and I want to use Joel's network and Jared's network together in some way. And it seems like we need to at least try something and present that to folks. And that for me is a key thing that we need to focus on, is not so much this application is broken, but we need to try something and we need to provide something for the people who use those applications to follow.
Did we want Willem and Andre to discuss the experiment?
They've got some stuff too, but these people really wants to yell at me.
Dan looks like he's ready to read from a laptop.
Channeling Tony Finch. My view of A name, et cetera, is that RFC 973 fixed inconsistency bugs in CNAME in the wrong way by making CNAME very awkward, so we need a better fix.
Interesting. He went deep on that one. Thank you, Tony.
So, and I was actually sitting up here for my sake to say to Wes, this isn't a protocol, thing. This is a user thing. Like the use of DNS has evolved. And we're getting that feedback back in here as an operational group, that the use of DNS has evolved and the use of the way people use it out there, because people don't want to type in www, that whole, in the space, in the web space, in the HTTP side. So the user community outside of these worlds, and that's really what we're looking at, is then how do people who publish websites respond to that change in user behavior? How do we make it so that those things work that way? And the reality is, if we don't come up with a solution, people will continue using the CNAME thingies from the other big providers out there, and they will wind up being stuck into centralized, proprietary systems, because of the fact that at the end of the day, I have a business goal. I need to make sure that my website works at internetsociety.org. All right? I got to have it work there. It's got to be there because that's what people want to use in some way. All right, now mine does work and it's focused on www, but let's pretend. Okay, I want to be able to do that. I have a business goal. So if my business goal is that, and some vendor says to me, I can do it for you. It's simple. You push this button, boom. All right, now maybe it means they have to own all of my DNS and everything else and all that stuff, and I have to host with them and everything else, but I'll do it because my business goal is that example.com has to be there without www. So if we can provide a standardized way, then we get to a system where we're not forcing people to go into closed proprietary clouds to go make that work.
We can slave zones, we can do fun things like that. So, Murray, I know you have something great to say.
Murray Kushravi, future DNSOP co-chair. I hear Joel's the first one that said something. Dan just said some of it, and it seems like we're driving a protocol change down at this level for a change way up in meat space, and I'm a little bit. But those make me nervous. And there may be no other way to do it, but we really need to be careful about doing this because next month users might say, well, why can't I leave COM off? And you just know what the hell I'm talking about, right?
Yeah, exactly. So, or we'll just insert ARC records as how we actually communicate to each other.
Yes, there's a potential very far away horizon where this is solved, and you're welcome.
No, and I agree. But I think we're smart enough that we should be able to sort all that out.
Let's make sure that we go after you to Andre.
Yeah, to Willem and then Andre, yep.
Well, about the experiment, so we have something concrete to discuss.
Lars Lehmann here. I am really not comfortable to approach this from a user convenience angle. I do understand the multiple lookup problems with an SRV record or something similar. So that's why I'm willing to look at a new record type that kind of combines all the lookups into one for whatever. You already have a second lookup that you need to do, because if you follow a CNAME today, it ends up in a name, and then you have to do a second thing anyhow. But the complexity thing, we have software to solve that. No one writes HTML code by hand anymore. There's a reason for that. It's complicated. So we have software tools that help us with that. So I see a business niche for someone here. I'll take it if you don't, to stand up a online service, configuremydns.com, where you put in what you want to have, you press click, and you then copy and paste what you need to do. Yes, please. I handed it to you, so you're welcome.
No, thank you all. No, it's all good feedback. So we're just, I think we all want a path forward, right?
Yeah, so I shall try to give a implementer's perspective, not the implementer's perspective. There's also a lot of repetition of things that already have been said, but I'll try to skip over that quickly. So CNAMEs at the apex do not work because of this statement in RC 1034 that no other data should be present. Then there's a CNAME. And so resolvers and authoritatives and all name server software took this as a rule, and so it's just not allowed by the software. Also in DNSSEC validation, bits are tested on NSEC records, and things will not validate if there is a CNAME next to some other record. So from an implementer's perspective, standardizing on CNAME at the apex or together with something else will be very hard because there's no incremental deployment. All the resolvers have to be adapted first before people can actually use that feature. So there was a proposal already 8 years ago, which has very recently been updated, I believe, but we'll come to that later. So this has all been said, I think. So the SRV record, that's also with my implementers had on perception. It's not a DNS problem. DNS can help in resolving the issues with using SRV. Like, for example, we could put the resolution of the SRV records in the additional section, DNSSEC signed, so it's solid to use it. DNAME, there's DNAME, but it does work for everything example.net, but not for example.net itself. So it's not the thing that the users want. A name expired on my birthday last Sunday. But I think it moved forward and it addressed things that, for example, the offline signed DNSSEC, there was a solution proposed for that, and so, I don't know, I guess it could just be picked up again to work on this, from my perspective. But there's a new draft also posted on my birthday last Sunday. And Andre is going to present the idea of having the CNAME plus DNAME at the parent right now. So, Andre.
So this hackathon, I ran this little experiment because we talk about it a lot, and in a great tradition of running code, I wrote some code. So the goals of the experiment during the hackathon was to put the CNAME plus DNAME in the parent zone and to see what works and what breaks. And the other experiment was CNAME plus DNAME into Apex, put them into the Apex of the zone and see what works and breaks. I hacked up the bind to allow the CNAMEs everywhere, basically. And I have it running somewhere on my machine, and these are real names, so you can, well, no, please listen to me, then go play with them. So these domains do exactly what they say. And if you want a domain email, I will send you the contents of the zone so you can see what's there. The CNAME at the apex. I tested the bind, Power DNS recursor, unbound, not resolver, Google public DNS, VeriSign public DNS, that's probably running one of these. Quad 9 is running mix of Power DNS and unbound. Cloudflare is running not resolver. So, and I did this in different scenarios. So this is like, and the result is that most common case is that the CNAME masks everything in the apex, even the SOA record, NS records, MX records, everything. It sort of works, but everything is like redirected to the target domain. And I'm not sure this is like, what do you want? If it's orange, yeah, as you can see, I learned to use the colors in the presentation. Next step is the Comic Sans. So if it's orange, then it redirects everything but the SOA record. Probably gets cached somewhere or something like this. I don't really have an answer for that. These are just preliminary results. So so this looks bad, right? This is probably something we don't really want to redirect everything, but maybe users want it. But again, these are just my findings. So for CNAME plus DNAME at the parent, it's much better. So if you have a, like, for example, I have a domain www.cname plus dname.rocks, that's CNAME plus DNAME, then almost everything works. The reason why Power DNS recursor fails here might be that there are upcoming fixes to DNAME in Power DNS recursor 4.2. So I filled the bug with them to solve the case as well. But if you put CNAME plus DNAME into the parent zone together, then almost everything works as expected, including DNSSEC. I forgot to say these domains are DNSSEC signed, and they have a valid chain. The other problem is with not resolver that the DNAME returns all the records it should, and then it resumes server fail along with that. So that's probably a bug.
Andre, before you go on,
I think you have a
clarifying question. Why NA in some of those columns?
Because they don't support the feature. Because there's the queue minimization.
The server doesn't support.
The server doesn't.
Thank you.
Okay. Well, the recursive server doesn't support the queue minimization.
Sorry, Tony Finch had a mic. He said BNAME is being resurrected from the dead, question mark. CNAME plus DNAME is not a solution to the CNAME plus other data problem.
No, it doesn't tell us that. And I'm just reporting my findings. Do whatever you want with those.
Yeah, go ahead and finish, and then we have a few more minutes for discussion.
So, again, I said, these were DNS signed, so this is the graph from the DNS base. It looks cool. And I resurrected my old CNAME plus DNAME draft back from the days of DNSX. So please don't be harsh on that. I really just did a quick update, and Vicky told me my English were horrible. It was horrible at the time. So if we want to progress this, I don't know. It's up to the working group. I just found that if you put the CNAME plus DNAME, similar what to Roy has said, it sort of works. So it might be like interim solution before we come up with something that's like well designed. It doesn't really replace a name. Because it redirects everything. Like this is this is no, because a name is only for a and quote a, but the CNAME plus DNAME redirects the whole domain to like different part of the tree. But it provides a quick working solution that's deployable right now because everything mostly works. And it like scratches the itch that, for example, people with IDN domain has, or so the problem space and the social space is a little bit different than the A name. But it's worth thinking about that it might be a solution. Also, it will like need the TLDs to support this. But if the TLD wants to like support IDN in a very lightweight way, that might be a way forward. Like put CNAME plus DNAME, sign it, and then redirect all the IDN domains to the base domain. So I have a couple of questions with that, and I think I solved some of them with discussion with Mark. That it might be good to return the DNAME along with the CNAME for the owner query, so the resolver knows about the DNAME before it like gets to the other part of tree. That maybe the NSEC might help here, but again, this is the deployment program. We would have to upgrade all the resolvers. So, so I'm not sure if we should make the NSEC mandatory for this, but it might be a little bit helpful because there's information that there's a CNAME and DNAME in an NSEC record. But again, this would need some protocol changes. Now you can eat me alive.
Yeah, we do have a few more minutes for additional discussion and to see where, if anywhere, we've gotten on this.
Yeah, John Levine. First, I must say I am astonished at how many OKs there were in your chart there.
Yeah.
And I think that this is worth writing up. I would not suggest progressing it because, as Tony said, this is the B name issue, which is it's a totally CNAME plus other records of the Apex tend to be for stuff where like your mail server is here and your web server is there. CNAME and DNAME at the Apex it's an ICANN problem where it's like I have this Chinese domain and that Chinese domain where the characters are written differently. And we've gone around and around and around with that. And the conclusion I have come to, which I think a lot of other people have come to, is that this is primarily an issue of the problem they're trying to solve is primarily a problem of provisioning the application servers. So like when, you can put in a DNAME, like back when .cat had DNAMes, you would register something .cat with accents and you would DNAME it to the equivalent thing without accents .cat. And I looked through, I just sort of did some samples, like how many of the web servers in .cat were actually provisioned to handle both names. And the answer rounded to 0. So it's an application provisioning problem. And I said, by the time you can provision the applications to make your mail server work and your web server work and your chat server work, spitting out a couple of zones to make the DNS correct is like your easiest problem. So I basically, having rambled, the summary of my suggestion is, this is cool, write it up, but please do not progress it.
Also, I forgot to say that the reason why there are so many OKs here is because the CNAME is like mutually exclusive from the DNAME answers, because like the CNAME targets the node and the DNAME has everything under the node.
Oh, yeah, I understand sort of semantically why it worked, but this is a code path that nobody would have tested that just seems to probably work by mistake in a lot of these places.
Yeah, maybe. Or maybe because nobody optimized to look if there's a CNAME upper in the tree. And it's probably the right thing to do.
Yeah, it seems that this provides data about how the world actually works. And there's also a discussion that we should probably continue on the mailing list about how the world ought to work. And how big is the gap between them?
One of the actions from the group last night is they were talking about setting up a separate mailing list for this discussion. So if you guys as chairs have feeling that shouldn't happen elsewhere.
Oh, no, I think it should. And that maybe, because it may be that this is enough that we spin up something just very specific as a working group, just to sort of, attack this, right? I don't know.
Ben Schwartz. I'm sure most people in the room know this, but maybe some don't. So I just want to mention that Quad 9 is using Power DNS and Cloudflare is using that resolver. Yeah. So those patterns of failures make sense. And it's essentially the same error.
I've been told by Peter van Dijk that the quad 9 also uses unbound, so you get inconsistent results from quad 9. That's what I was getting when I first tried.
I do think we want to work with the HTTP people. I think that conversation yesterday sort of led me down that path, that I think we need to figure out some path forward. Yeah, sort of see if we can sort of bridge that gap. And yes, but yeah, and the minutes that Shane wrote, I think we're going to add them to the minutes that he wrote. We're going to add to the minutes for Dnsop. And I'll probably send out a note about that. Mr. Hoffman.
No, please don't.
Okay.
It was explicitly a side meeting, names were not kept and such like that.
Okay.
And, Shane, yeah. So for those of you who weren't there last night but have read Shane's notes, I think Shane's notes has a significant error at the end that very much affects this, which is there was a question asked, who's interested in working on this forward? And a bunch of hands went up. And like everyone was like, great. And then someone asked, how many of those folks were web developers? And it turned out one person raised their hand up halfway, and that was it. So, no.
Yeah.
Actually, I just got, Tail agrees with me.
From where I was at the room, I saw maybe 10 people put up their hands when asked who were the web guys in the room.
Without having an argument here about what happened in a meeting most of us weren't in, I'll
This
just
is why I
say,
don't want the minutes to be part of it.
I will suggest that people who are interested in the topic read the notes that we can discuss the notes. But I think more important than what happened in a side meeting yesterday is how much interest there is in working on this. And if it turns out, we're happy to host the discussion in the Dnsop list as long as that's appropriate. If we find that there's a gap, for instance, that there's a different set of people that need to be there, no objection here to another list either. You know, it's a question of having the conversation and making sure that people that want to do work have encouragement and support to do well-reviewed, useful work.
Shane Kerr. So I have many opinions about all of this, but I'd like to address the question of this side meeting and where the documentation about what happened there should go on.
Out of scope. Please regard it as settled that it's not part of the NSO. Sorry.
I'm not sure where the little clicky went to. Here it is. Maybe it reaches a little bit.
Okay, so can you hear me, folks? I'm in the unenviable position of following that exciting discussion. But, since I'm here anyway, I'm going to blurt out my opinion. I think we should just design a new generic type-specific alias, get everyone to deploy it, problem solved in a decade in my fantasy world. But anyway, so I'm Shuman, and this is the multi-provider DNSSEC draft. The other folks that are helping out with this draft, I think are all in this room. It's Pallavi Aras, John Dickinson, Jan Chelak, and David Blacka. And in response to some interesting comments I've heard about this draft, I'd like to suggest that the subtitle of this talk is How in the Modern Age Do We Get an Operational Document Through the Dnsop Working? All right. So, okay, I can see down here, right? So this draft is about deploying DNSSEC in zones that are signed independently by multiple distinct DNS operators. I'm not going to go through the details of the draft again because we did it last time, but if you're interested in reviewing that material, there's pointers to the slides and video from IETF 101 in London in March. Okay, so I'm just going to walk you through the updates that we've made through the draft since the last version that we presented. There was expanded text in the signing algorithm consideration section. And there are 2 new sections on authenticated denial algorithm considerations and key rollover. And there's a couple of additional edits in progress, which we haven't published yet, but we'll probably put out by the end of the week. So the early versions of the draft had a lot of material in the front end that basically presented a kind of a taxonomy of possible deployment models. And really the most interesting part of the draft are the new stuff, the multi-signer models. And let's see, David Blacka in particular felt very distracted by the by the taxonomy section and argued that it arguably took away from the focus of the document. So he suggested to me, and I agree that it was a good idea, that we just try to just pull out the entire taxonomy section and instead have a kind of abbreviated introduction that kind of motivated the use case. So talk about why the traditional zone transfer models do not work in these specific scenarios and why you might want to consider the new multi-signer models. And the other bit of news is that we deployed prototypes of both multi-signer models during the IETF hackathon over the weekend, and we confirmed that they work, which is what we expected, although there's more testing to be done, which we're planning to do in due course. And I think we're here to answer questions and comments and critiques of the draft, but I think I'm just going to turn it over to the chairs to conduct this part of the discussion about adoption.
Yeah. So we did put it up for adoption. We've gotten some good comments on the list, and pro, a couple against. So, and understood, but please, if you have comments or you want to come up and, don't yell at Shuman the same way you yell at me. It's okay. Be nicer to him. He works with me. Be kind to him.
You can yell at me. I have a thick skin.
Okay. So, but we think it's informational. It's operational. It's good guidance. We're not breaking anybody's, forcing people to do stuff, but it's something that is happening now, and we're trying to do, but I think other people are trying to do as well. And it's like, so, please take a look at it, please read. And we've gotten some good feedback in this week, but, call for adoption's up until Friday, so, throw your opinions out there. Anyone have strong negative opinions, please stand up and yell it. No. Sarah does. Yeah.
Sarah Dickinson. I think this is a draft that should go forward. I think for the operational community to be in a position today where they have to make a choice between multi-vendor or DNSSEC, and they literally can't do both, is really hampering deployment of DNSSEC.
That sounds very similar to the discussion we just had about stuff at the Apex, doesn't it? Yeah, I know. It's okay. I'm not going to beat that.
I have one comment which came out of a discussion yesterday evening on something that might be useful to add to the draft, which is that we already know moving vendors is difficult when you're doing DNSSEC. Does this model add any more complexity to the problem if you've deployed with two vendors and then you need to change one or both of them? So maybe we should just have a discussion section, either saying we don't think it adds problems or hang on, we thought about it, it does.
Right. Yeah. So I agree. That's a good point. So that was on my to-do list. I'll start with your second point first. Yeah, migrating from one provider to the other. How would you do that in this configuration? I think actually the mechanisms proposed in this model about synchronizing keys across providers does actually help you. So I think that's a section we can add to the document. I think we're already planning to do it. So I think we can address it there. On your first point, yeah, I totally agree. So, I mean, if we don't have a solution to this problem, this effectively excludes a bunch of people that have deployed these multi-provider configurations from deploying DNSSEC. So they have a choice, DNSSEC or no DNSSEC if I want to do this stuff.
Other comments? Okay.
Okay. Thanks, Shuman. Yeah.
Daniel, so are we going to ask for adoption?
The call for adoption is already open on the mailing list.
Oh, right, sorry.
It runs through Friday. So. Yep.
Morning. Probably wondering why I'm probably all here. We're going to bring up the both RR draft again. So, the big changes for this, version is we have changed the intended status to informal. Oh, thank you. So, we have changed the status to informal. We've spoken with a number of implementers who are very interested in implementing this and want to see it go forward. So we're hoping that this will help it run through the paces a little quicker. And that's really all I have for this. So,
how many folks in the room have read the bulk RR document, considered the? Okay. Views on whether it should be further considered as informational?
I just wanted to mention that this was another one of the cases where a lot of the relevant stakeholders are unfortunately not participating directly here. John has been doing a lot of the work like at Nanog, and actually has quite a few operators that really do want to use it, but they're not here. And I will beat John Levine to the punch and recognize that there still is one interesting issue here that Dnsop has not frequently had to confront, but that is when you have an RR type that is going to change authoritative server behavior, we don't have a really good understanding right now of how to signal that when you want to secondary your zones on different servers where one might have the new feature, but then one of your secondaries doesn't. So it's still really an interesting aspect of this whole thing that I think needs to be considered in a broader scope beyond just the bulk RR proposal itself.
I took a look at Mike St. John's. I took a look at this, and the thing that struck me was that it sort of intends to break DNSSEC in interesting ways, and it's sort of a weasel wording of, well, you could do this, or you could do that, or you could do another thing, or you could sign online or things like that. And it would be nice to have a much more baked statement on that, rather than, I don't know that I think this is ready for adoption in the current form because of that particular set of problems.
Okay, so thank you. We are trying to work towards some more solutions with the DNSSEC side. Thank you.
Hi, Shane Kerr. I took two questions now. So my first question is, if this is informational, can it move forward to standards track later, or does that have to be experimental? Informational can?
Yes.
Okay, cool. And the second question is, does a document have to be done before it gets adopted as a working group document? That's a bit weird, I think. No. Yeah, okay. So I agree that we can definitely add clarification in the DNSSEC section, but I don't think that should block adoption. Thank you.
Okay. Knowing that once it's adopted, you have to fix the DNSSEC part. And it can't move past that until that gets done, essentially.
Right.
I'll just write up. I'm also a little confused about the informational status, because I would expect this to be either an experiment or a proposed standard. And informational seems to me like I could not read this, but it's actually defining a new RR type. So I'm really confused how that can be informational.
Do you want to answer that, or shall? Okay. Let the chair who knows better.
Not to dive too far into the process weeds, but the registry policy is expert review, and in many cases, we do not have to have a standards track document in order to delegate an RR type. In this particular case, given the possible complexity of processing, we probably do.
But that still doesn't answer my question, why isn't this an experimental?
Yeah.
That is in fact a different question.
Yeah, and it could very well be, oh, we got an AD up there. Oh. Get the spray, yeah.
So Warren Kamari, if this does end up being experimental, there's going to be a fairly strong push that it needs to very carefully explain what the experiment is and what the excess of failure criteria are.
So if anybody wants to make it experimental, please, provide text on that, how we would have determined what the outcome was.
Yeah.
Okay, thank you.
John Levine, I was going to say more or less the same thing as Paul, which must be unprecedented. But to me, this smells like an experiment. And I think the experiment is, can people actually figure out ways to implement this with DNSSEC that works, is the fact, I think creating an RR type that requires online signing is a fairly significant change to the model. And then there's sort of the whole meta question of, the way we've done this stuff historically is we've come up, I have zones that create zillions of records on the fly, but I use stunt servers for it because I don't see what I'm doing to be ubiquitous enough to try to push it into a regular DNS server. I guess the other thing that would be interesting for an experiment is, presumably the point of standardizing this is so that you can kind of do expansions in consistent ways with I have a primary and a secondary, and I want them to expand in consistent ways. I think another interesting question for the experiment would be, what sort of expansions do people actually do? And does the pattern language you propose actually match what people use?
Okay. Yes. That's a very good question. I was approached by, or actually my colleague was approached by a number of vendors at Nanon who did recommend to do informal, to switch the status informal to move it forward. I'm not opposed to going the experimental route. This was just a recommendation.
Ray Bellis with my expert RR review hat on. This can't go to expert review. So this cannot go to expert review because of the additional processing required. It's not a plain data RR, and if it's going to early allocation, it has to go standards track.
So yeah, it can't go to expert review, and the expert gets to say, no, it needs further consideration in the working group. Yeah.
So Dan York relaying for Peter Van Dyke. Actually, I have two relays, but first Peter. He says, various posts on Dnsop have been asking, what problem does this solve? No answers have come forth. What does this solve?
Okay. So this solves the problem with having a number of records that would generally be solved by $generate or similar macro technology to be able to transfer those records from one server to another server in a master-slave relationship. For example, in a large ISP, you may have customers that want to be able to own their records, but have a copy of them in a more reliable environment and send that information, but they're too large to actually parse through all of the possible permutations. So being able to transfer the record is a big problem that we're trying to solve.
Okay. Yeah, so, hi, Jared Mach, real quick. I think the problem is if you try and generate reverse DNS for IPv6, your generate will take quite a while, and let me know when your zone transfer ends.
Don't go away. So this is a theological problem. I mean, there are people who believe that having generic reverse DNS for D6 is a good idea. I am not one of them. So I think that goes back to the question of, does this solve a problem that should be solved? Within V4 addresses or within any, enumerable, if you are actually enumerating the addresses of actual devices, I think it's fair to say that with modern DNS servers, your zone will be maybe large, but it will be tractable.
Well, we've seen zones above 100 megabytes that fail to transfer reliably because when they're expanded. So this is like one of the real world things we're trying to solve. And you're right, there are a lot of people that want to see generics just go away. But today, this is the ecosystem we're looking at.
Yeah, it does sound possibly one of the outcomes of an experiment will be to determine whether the need is really there and just not represented in this room as an earlier comment suggested.
So I have a second relay, or Mark, are you responding to this point? Okay, so the second relay is from Tony Finch. Oh, wait, okay, so wait, Peter just responds back and says, that's it, we don't need to fix, improve, generate into bulk, we need to kill, generate. All right, well, on that note, we will move on to Tony Finch, who says, I think IPv6 placeholder reverse DNS can be done adequately with a wildcard PTR, and there's no need to replace $generate for IPv4.
Okay. What if you want to zone transfers between power DNS and bind with $generate? I don't think that's possible.
That works.
Oh, does it work? Okay.
Because the authoritative $generate just creates some regular DNS zone.
And then it just pushes it.
It just pushes it. So, who's next? I'll take the. Okay. Most of this comes about in history because ISPs weren't willing to do the legwork to delegate to their customers the integrated ARPA namespace. We have the technology to do that all today automatically if we want to actually do it. We have update. We can quite easily put into, today we reassign DNSX zones and work out what has to be removed and replaced automatically by authoritative servers. We can use this similar mechanism to say, if you've put a PTR record in, the authoritative server will just remove it with a little bit of information at the time when it's supposed to be removed. So you've got your addition and your removal. We can authenticate PTR insertion by using TCP. NameD has had for 2 decades the ability to authenticate updates using TCP in the reverse tree. I put it in there so that this sort of thing can happen. We can authenticate that down to the state where only a PTR record is allowed to be put in via that mechanism, and only for that particular name that matches to the IP address. This is solvable without this stuff. It does require the client to go and register the PTR record. But if they want a name, they should be doing that.
Mark, what if it wasn't AMPTR or whatever the C name? So I have a zone of 900 megabytes that's all C names that we could probably...
We can do with C name as well. Okay. The authentication mechanism we've got in there says which types we will let be added. And we can have the server, if we want, automatically generate a timeout record and process that and get it out of the system. This is stuff that can be done. So it's not actually hard to do. It just requires somebody to do it and say, yes, we'll let ourselves take a couple of update requests. People are just too scared to do what the protocol is capable of doing.
So a lot of times, and just the first thing you mentioned, that the ISPs don't want to delegate the problem to the customers. A lot of times the customers are not technically savvy enough to manage their own, or they just want a copy of something that's managed at a larger professional level. So
we write an RFC that recommends that CPEs and hosts, if they're not running Active Directory, because Active Directory does all this today. Microsoft did this for Active Directory. Their hosts go and update their PTR records in the DNS if you're running Active Directory. We can do all of this. They have to actually update both the forward and reverse. We can do all of this with SIG0 for the forward side and TCP for the reverse. We can authenticate both things. It requires a document that says, do this. This is all old stuff.
Okay. Just point of order, I'm closing the mic line.
Mark? Yep. It does require a document that says do this, but before that, it requires a document that says how to do this, because I have no idea what you said. And I consider myself to be moderately technically savvy, not in the world of DNS. But I think we should do this. But somebody, I hope you're going to volunteer for this, is going to have to go to V6 Ops and say, if you are an ISP with a moderate to low level of technical clue, here's exactly what you need to do. And if you're a CP, here's exactly what you need to do. And I think if you want this to happen, someone has to write that document. I would really love if somebody did.
Well, Warren just wanted to stand up and say that he wants to be able to sign these reverse zones in V6, and I wanted to make some. Is in the DNS space is really quite an amazing claim to make, given the number of ways we try and push the DNS protocol in all directions. And even if you're using incremental updates for, Tim's zone, he still ends up with a 900 megabyte zone of CNAMEs, right? Like, so V6 reverse is not the only use case. The CNAME mapping case is another one. We have encountered others. One other way that Generate has a problem that I don't think I heard John mention was that it also has a real hard problem with carve-outs. They've encountered this problem operationally. Like if you have a special record that kind of breaks the pattern in the middle of the zone, you actually then, your Generate, like say you needed to add a CNAME for some reason. All of a sudden, your Generate pattern creates an invalid zone. You have to fix that up with then making two separate Generate problems. And then the idea, while I can appreciate the sentiment of saying, oh, well, then we should just do away with dollar generate, that doesn't actually make the use cases go away. It just means that now people are creating their own head-off solutions for how they're going to build these zones. So, thank you.
So just a point of, Ted Lemon, just a point of information. There are actually several drafts that talk about the whole update thing in HomeNet. And there's one in DNSSD as well.
So Tobias Wichtierdorf. So I think there was earlier some question about like how often this case happens. And if we're looking at reverse DNS measurements, we see that around 15 to 20% of those are already doing some form of dynamic generation for PDR records. And I think there's a current draft in the V6 Ops talking about how to handle reverse DNS/PDR for V6 deployments in ISPs.
Right. So that is one of our use cases is to implement this on the V6 side as well. It's not specific to V4 or V6. I'm not sure if I heard the entire question.
I was just going to say, John, thank you for bringing this here. We have been asking for quite a while to have operators bring real operational issues that they're having into this group. So I would want to just say thank you for bringing this there. And I would say to Mark, or to, again, these are the issues that people are seeing as they try to solve the business realities of implementing this stuff. And I understand where John's coming from in this. And we may not like it, and it may not be the greatest idea of what's out there, but it's trying to solve these real issues that are being out there in the deployment of things.
Thank you.
And again, we have yet to figure out how to upgrade the global DNS when we think something's a bad idea.
Yeah. Thank you. And there are a number of vendors that are currently implementing this in one way or another. And I'm trying to just wrap it around a common mechanism that we can use to transfer between the various vendors.
Thanks, John.
Yeah, thanks. And I think it's an action item for the chairs to go make sure that we work with Warren on exactly what would be involved in going experimental with this.
Yeah.
Because that actually sounded fairly promising to me.
Yeah. Okay. Thank you. Yes. Yep.
Hold on. You need a little cleaning thing, sir.
Okay.
That's good.
So this, I gave this presentation at the ICANN IDS meeting, so this is a really shortened version of it because everybody here is a DNS expert. So one problem with DNSSEC, when we start using this as a hierarchy of trust, is that, you know, parents are not as trustworthy as we might like. They might be coerced, they might do things that we as a zone don't want. Most people believe that the most powerful keys high up in the hierarchy, such as the root key and the TLD key, will never do these bad things. But there's people who say that, you know, as long as this system is rooted in the trust of those high-level, top-level domain and root keys, then we cannot trust this because it's all under control of governments. So that is one part. And the other part is that we really want to do DNSSEC transparency, and we currently cannot do that because of a few limitations. So what are the attacks that we actually need to prevent against? So one of them is the sort of the deep link attack, right? If the .org domain says mailarchive.ietf.org, this is the public key or this is the A record, and they can just skip the delegation for someone. And the other attack is, of course, that a parent can just take over the entire tree and sort of put the child out all by itself, and no one will hear it scream. So the proposed solution is to add a bit to the DNS key flag that says, I expect my parent to behave, I will commit publicly to never deep sign. So a parent will say, so for instance, .org, if it sets this bit, it will say, I will only do delegations, I will never sign anything deeper beyond one label cut. So they will not, so if you see an RR-SIG for something in mailarchive.ietf.org coming from the .org TLD, you know that this is, you know, this is a false record and they have been coerced into signing this, or they lost their private key or something. And the good thing is, because it's a DNS key bit, it actually reflects in the DS record. So once you do this at the parent level, and the parent submits their DS record upstream, it actually gets published to the world, and the parent can just sneakily change this without actually changing their DS record. So either this needs to be a really advanced targeted attack where you are an empty cache and you will get the DS record from the root down and it's all new, or the DS record will be completely different, including the key tag.
Stuart, just a quick clarifying question. Can you go back one slide just quickly? I think there's a little additional nuance here where you say delegation only. I think it's implied delegation only one level down.
That's correct.
But you can't sign a delegation 2 or 3 levels deep.
That's correct.
So it's not just delegation, it's like all the levels below me are leaf nodes.
Correct.
Okay.
Yes, this is not I guess bind has another definition of delegation only. That's a little confusing.
I don't see why this can't be multiple levels. The thing is that you get back a referral, or you get back a node, an NX domain, or an empty non-terminal. Those are the only responses you can get back. That's what we did when we were doing delegation only in named. That's all the things we're looking for.
Mark, thanks.
Okay, so like I said, the benefits are it's a public commitment by the parents, so it's much harder to do targeted attacks or coercion because this is like broadcast everywhere. And the good thing is that we can do DNSSEC transparency because we no longer need to worry about these deep signatures because they will all be invalid because of the bit. We only actually need to log the things that we care about if the delegation gets changed on it. So we only need to log DS records and DNS key records, and then if there's some sort of targeted attack, then you actually have all the cryptographic proof to then shame the keys publicly and see what happens. So I tested this out. So if you want to try and resolve powerbind.nodes.ca, it's setting just a random key flag. Like I just stole a bit, I squatted it, and I just wanted to make sure that all the resolvers behave properly if they're not updated to this new flag. And it seems it all works. So bind unman power DNS and all the quad servers seem to be behaving properly. So this way we have some additional protection, and especially important is like the TLSA records, right? Like those are public keys, and we really want to make sure that those are not being coerced, and we have strong security on that.
Some problems, or at least some less nice properties would be, so first of all, as Mark said, we've got the empty non-terminal. So people like co.uk, or I think dns.nl, they would have to split up the zone and create subzones designed this properly. The second is that it doesn't protect all the records in the child apex itself, but those tend to not contain public key information or fingerprint information, so it's actually not a problem. If you assume that A records and Part A records are not worth protecting because someone can steal your route. If you're at the coffee shop, you don't know who's answering for 101.1.1 anyway. You're really relying on public key material to see that you're at the right spot. And the other annoying thing is that we introduce a lot of prefix labels to signify certain services like the TLSA record and the DKIM records. And we could maybe have an exception for the prefix one, so we don't actually have to create these NS and DS record delegations in between. And while I was walking in the IETF hallways the last 2 days and sort of suggested this to people, I got actually two good ideas. One said, if you're setting this flag, that means that I will not skip anything under my child. I will let my child speak for itself. We're really also implying that your parent cannot undo this commitment for you. So it actually works both downwards and upwards. So if you then see that so let's for instance say if noads.ca is skipped because the route goes directly to noads.ca and they skip.ca, and that's not what you would expect either if this DNS flag is set. So you're basically also setting a bit to say something about the parent not skipping you. So that adds a little bit extra security, and it also would mean that the root doesn't have to set this, because if .ca sets this flag and say I will never skip my children, you should go only follow delegations. It also kind of means that the root should not be able to override that commitment by the CA key. Like I said, if you do the exemption for the underscore prefix ones, that would be good, because the regular host names cannot have an underscore in it, so it really only addresses services and it doesn't affect existing host names. And then one other idea I had from someone was that we could also use sort of 2 bits instead of 1 and sort of get a sort of equivalent to path length. So we can actually handle the empty non-terminals that way, so we can skip a zone. And with that, I will take questions.
Hi, George from APNIC. So 2 different points, but they might be versions of the same thing. If you had this, and if you had a complete chain from some terminal delegation point all the way up through the zone cuts to the root, then if you're thinking about query minimization, the hunting problem of where is the zone cut has actually been solved, hasn't it? Because there is an explicit signal all the way down the chain for every element of zone cut, which means the algorithm of finding the zone cut implicit in query minimization has effectively been solved.
So to a point, because you're like if you're an empty cache and you ask for your nodes.ca, you could still get a deep sign directly, right? Like you don't know if there is a zone code or not, but if you're told that there's not, how do you have any reason to believe it? But if you now follow this down back, so on an empty cache, this doesn't actually work. So you're still going
True, on an
empty
empty state
cache.
it doesn't work, but for a cache-prepped resolver, if you have the signal in the DS and the DNS keys over the zones you're looking at, I don't need to worry the question for sister zones because they just said they don't do it.
Right.
Yes. That was the first part. The second part is kind of a counter statement, which is it's because of things that people say to me in X509 PKI. Children cannot force parents to behave. And so this is a statement of intent that says if you see this, you can't go there. But if you're thinking about the path hunting down from the root, the parent can always say, no, you don't go down into that thing. You just go over to this 3-dotted label. If you are not in DNSSEC, it doesn't work.
Yeah, and that's why we still need DNSSEC transparency. So if the parent does something like that, we have an audit trail for that.
If I can just relay from Peter Van Dyke, all parents above me cannot skip my delegation should be observed validator behavior today, even without power bind.
But they can actually remove the NS and DS delegations briefly and serve a real label skipping record.
Yeah.
Can I? Thank you. Roy Adams, a few observations. Can you go back one slide, please, if it's possible? So Coda UK is not an empty non-terminal.
Sorry?
Coda UK is not an empty non-terminal.
Sorry, I did this from the top of my head. Okay. I should- I should be right. Okay.
The other thing is, assume for a second that the parent does this trick, right? Has a delegation only. And just for clarity, you need to clarify a little bit more. You don't have to do that now. The difference between delegation only and single label delegation only. Right? You can delegate two labels down. But
right.
That's just clarification. A parent that does this, the transparency flag basically, can still be coerced not to do deep linking, but that one label down, it can actually delegate somewhere else under its own control.
Yes.
And then do the deep linking.
Yes, so again, that's why you still need a kind of DNSSEC transparency where you will see that they change keys because they don't have the private key, right? So they have to change the private key in the DS record of that child zone, but they're taking over.
Sure,
and so you can log that. And then, I mean, yes, like that will always be the case. But without this, you can actually not log anything because you don't know how deep to go. So you have to basically log all DNS data, which you cannot do.
Yes.
And with this, you're limiting the logging of DNSSEC transparency to only the DS and DNS key records and the deep link records.
I'm just trying to limit the level of coerciveness that you're trying to protect. And the other thing is this seems a bit similar from a naive point of view as the label counter in the RRSIC records, where you basically say, I've signed this many labels, and this is to protect against wildcard stuff. So that's just an observation.
Right.
Yeah. Thank you.
Matt Poundset, I have a question about how this interacts with real authoritative data in what is normally a delegation-only zone. So, for example, Apex TXT records, glue that's been orphaned by delegations going away, that sort of thing. What would happen under normal circumstances with those types of records?
So the TXT records and everything, that's just fine as long as they don't contain more than one dot. So if you're not actually skipping a label. For the orphan glue, you're right. So any zone that vanishes and you take on the orphan glue would then be considered an illegally signed record and would be rejected.
Yeah. Okay.
To be fair, you shouldn't be orphaning
No,
anyway into
seems
the parent zone.
Yeah, that seems to be a fairly common bug in a lot of registry systems, though, that hasn't gone anywhere, right? And so I think there may be that should be fixed, but there may be a deployment problem here, though, because that doesn't seem to be getting fixed.
Right.
Ben Schwartz. So I think I may have asked this question on Friday, but so I'm a big supporter of DNSSEC transparency. I'm really excited about that. I agree with your analysis that DNSSEC transparency requires a commitment from the zone not to do deep signing. What I don't understand is why that commitment needs to be in the DNS or even machine readable. It seems to me that a commitment not to do deep signing written on paper for humans is sufficient for DNSSEC transparency.
But now you're only thinking of like the first level, the root key and the TLDs, but then
Yes.
this can go multiple levels down. Like how much paper do you want to add?
Okay, thank you.
Wes Herdeker, sorry, yeah, it's a scalability problem, Ben. No, that's really what it comes down to, is that if you don't signal it within protocol or signal it somewhere, then it's very hard for anybody to figure out, what can be logged and what can't be logged, and or
Sort of like the
what
public
should
suffix list.
right. So this is basically a we allow certificate transparency type logging to happen at this particular point in the tree. And, going back, that's really where all this stems from. I sat on probably 3 or 4 trans working groups where this kept coming back. There was a real desire to decide whether the root was lying to the world or not. And it kept coming back, and the end of that discussion, and it happened multiple times, was, well, to do that, you have to log every DNS response ever, received. And so it's an unbounding, right, no problem, right? It's an unbounding problem. This bounds the problem so that if an NS record even changes or a glue records change, that is now detectable with a transparency log, whereas before it was very hard to tell, without logging everything under the sun, including NSEC and everything else that it was needed. In terms of, did you want to respond, Ben?
Yeah, so the claim that I'm making here is that it's sufficient for to do DNS and transparency at the root. It's sufficient for the root on paper to say we're not going to do any deep signing beyond the TLDs, and then you can do transparency on the root. And similarly, any TLD, or I can by policy across all the TLDs, can say the TLDs won't do any deep signing, and then you can do this for all the TLDs. So I don't see this as a prerequisite for transparency logging at either of those levels. I do think it's useful for deeper levels.
You just made a technical error. You said ICANN can tell all the TLDs. That's not true. We can tell all the GTLDs, like the ones you folks own. We can't tell the CCTLDs to do anything, sorry.
And again, if this kind of paperwork solution would work, we would also have the public suffix. Like, the fact that that is still a hard problem to see where the split in authority lies from the browser point of view, it's not an easy way to maintain that list.
Can I jump in? I just want to make a comment on that point, which is what I wanted to raise. When we were first discussing these ideas a few IETFs back, I remember we were sitting at a table, and your assumption is most of the TLDs are delegation only, and that doesn't appear to be true, because instantly we had an argument from a bunch of TLD operators saying, hey, we have lots of deep names in our TLD, so you can't do this. Unless you impose a requirement that they have to create delegations at every label boundary in their net zones.
So that would be a requirement for using this signal. So I mean, TLDs are welcome to not do this, but then hopefully market forces will work and say, well, we will trust the more secure TLDs over those TLDs.
Sure, yeah, but I mean, you may be stuck in the TLD where you are,
sure.
right? And then you have this problem that this solution didn't solve, right? And then there's the general problem of leaf zone or enterprise zones, which are many labels deep, right? What are you going to do?
But because this bit also works upwards as suggested on the last slide, you could actually have noads.ca without CA committing to that bit. And then if you once get to noads.ca, you know that everything above it is not supposed to skip you either.
Mm-hmm. Okay.
Okay. We only have a few more minutes in the session, so last call for the microphone.
Yes.
Go ahead.
So I'll continue. Wes again, ISI. As aggressive co-author, I should mention I'm a co-author. So Paul and I have had some discussions about this, but really we would like feedback on especially these bullets in terms of what should go into the document. Don't change the slide on me. I was about to talk to them.
These ones.
In terms of how simple or how complex to make, the signaling. My example was the whole exception thing. Well, you could create new subdelegations and deal with it then. There's ways around it, whether you should include a depth. My suggestion for the does not protect child APX data would be, we limit the types of things that a zone with that bit set can do. It could include glue and, DS records and NS records, and that's it. And whatever delegation requires without, so it shouldn't be able to spoof child records at all. And then prefix labels, sort of the same thing. It's not really how it's designed. And then we've also talked about doing whether we should have one bit that signals both upward or downward, or whether we have one bit up and one bit down and things like that. So feedback on the list, because I don't think there's enough time here today to go into it, but please do comment.
Giovanni, SIDN, and Delta University. This is not related to the draft, but for the folks here in the DNS ops, tomorrow there's a presentation on MapRG. There are 4 presentations on DNS, so if you're interested, maybe you want to check it out.
Okay. Feels like we've done an awful lot of work this morning, especially for starting in the morning. I think that's
it.
I think that's it for now. For this draft, it does sound like more discussion is warranted on the list, and in particular, reviewers would be helpful, particularly folks with operational interests and needs here. Also, don't forget the CDNS working group last call open. If you haven't reviewed that document lately, go take a look at it and tell us if you want to publish it, and, or if not, why not. And tomorrow afternoon, we're the 6:10 to 7:10 PM slot in the big room next door. And I think that's it.
I think that's it. We'll let y'all go. Thank you all for putting up with us this morning, so we appreciate it.
And tell Benno not to run away screaming.
Yeah.
Thanks all.
Oh, yeah, Benno's going live tomorrow, so he's running the show. So, yeah. Oh, yeah. Oh, blue sheets, if you haven't signed the blue sheets, please do so, and then if you have them, please wave them towards me.